everybody, and welcome back to another fun and exciting intermediate math class. Today we'll be jumping into chapter number 5. Chapter number 5 is just more geometry. So last chapter we learned a lot about the terms and the different things that we would need to do geometry. And in this chapter we're going to kind of put some of those things to practice. If you will, go ahead and open up your book to page 176. Page 176. And look down here at the screen. We're going to start talking about area. What is area? Area is the amount of square units contained inside of a shape. What does that mean? Well, every shape, no matter if it's a circle or a square or a rectangle, doesn't matter what kind of shape it is, has square units inside of it. You say, well, a circle doesn't have square units, but if I draw a circle and I put it on like a grid, okay, or like graph paper, okay, it does have squares inside of it. And there are ways that you can count the number of squares. And you might say, well, what about like this little bitty piece right here? That's not even one full square. Well, you're right, but there's formulas that can help us to figure that out. So we're going to do the same thing with this shape that's in front of us. We're going to deal with this rectangle. So what I've done here is I've added like a little grid inside of this shape. Okay, I've taken these yellow lines and I've made a grid. I've made some basically like square boxes, square units inside of the shape. Let's say that this shape is 5 inches by 3 inches. So in other words, every one of these boxes would be 1 inch. So there's 1 inch, there's 2 inches, there's 3 inches, there's 4 inches, and there's 5 inches. Going up, you would have 1 inch, 2 inch, and 3 inch. Okay? So every one of those boxes is an inch. That's just what we're saying. That's not necessarily true. You could measure that and you would come up with something different. But for this example, we're saying that each box is 1 inch. Well, what we can do is we can tell how much space is inside the shape by counting the boxes. So if we go through the whole thing and we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. There are 15 square units or 15 boxes. So what was our measurement? Our measurement was inches. So the solution to this would be that there are 15. You could write it either way here. You could write square inches, or you could write 15 inches with a little square, with a little 2 up there. Either one of those is fine. It means the same thing, and they're both acceptable. So one is not better than the other. So a lot of times I'll write 15 square inches just because that's the way I say it. But you could also write 15 inches squared. You're going to see it both ways. So that's kind of the concept behind square inches, square feet, square miles, and behind the area of a shape. Now, one thing that you always want to do is you always want to write area with square measurements. Remember, when we did perimeter last chapter, we didn't use square measurements with perimeter because square measurements are the inside measurements, that's area. The perimeter is the distance around the object, and that's not a square. That's what's called linear. It's a line measurement. Okay? Now we're doing square measurements, the inside of the shape. Now, you might say, whoa, I don't want to have to count lines every time I do this. Well, good news. There are formulas. And maybe on this one you said, I think I know the formula. What if I take 3 times 5? That gives me 15 inches. And if we always write our units in square, there we go. 15 inches squared is the same answer that I got when I counted. You're correct. That's the formula for a rectangle. You just take the length times the width. So length times width, L times W. You might say, Mr. Steve, why did you put this R right here? Well, that's just, maybe your book puts area equals LW. I don't like that as much because it doesn't tell us what area. So I've used a capital letter R, and that means rectangle. Okay, so the rectangle area equals LW. Actually, it's a small letter L. There we go, LW. With a square, we're going to use a capital letter S for square, and that equals its side squared. Okay. Now, with squares, you got to remember that all the sides are the same. So if this is 3, and this is 3, and this is 3, and this is 3, we could actually plug it into this. We could plug it into length and width. We could say 3 times 3. Or we can plug it into this one where we just take the sides, since they're all the same, and we square it. So 3 squared equals 9, or 3 times 3 equals 9. You're going to get the same answer with a square, no matter which formula you use, but I tend to like the formula here, just taking the side and squaring it. It's a little bit easier. But if you like this one for a square, you can also use that. You will get the same answer. All right, so now let's take this shape right here, this shaded in shape, and now we have a shape within a shape, basically. We have a shaded in shape inside of the larger white shape. So the larger white shape is right here that's not shaded in, right? And then we have this one inside that's shaded in. So let's do a couple different things with this. Let's first of all figure out what is the size in square units of the large shape, of the white shape that's not shaded in, like the whole thing. Okay, so how would we do that? Well, you need to figure out what is the length and what is the width. Okay, so the length is 1, 2, 3, 4, 5, and 6. Notice that it says each one of these is 1 centimeter. So we have the length equals 6, and then the width equals 1, 2, 3, 4, 5, 6, 7, 8, and 9. The width equals 9. Now we're just going to plug that into our formula. What's our formula? LW. So we have 6 times 9, and 6 times 9 equals 72, and it's centimeters, so we have cm squared. So there you go. That the area of the big shape is going to be 72 centimeters squared. Now, how would we find the area of the little shape? We'd do it the same way. We'd come up here and we'd say, okay, this is 1, 2, 3, 4, 5, 6, and down it's 1, 2. So we would just say 6 times 2. The area of the inside shape is 6 times 2, or 12 centimeters squared. Okay, now, what if I want the area of the non-shaded part? So in other words, I want the area of this white part. I don't want this. I want to exclude that. How could I do that? Well, all I would do is take my area of my big rectangle, my 72 centimeters squared, and I would subtract my area of my small rectangle, my 12 meters squared. So 12 centimeters squared, sorry. So I would just subtract 12 right here, and I would get 60 centimeters squared. So the area of the non-shaded, just this white part, would be 60 centimeters squared. So we can kind of do some cool things there with just some simple subtraction to find the area of just the shaded part or just the unshaded part, depending on what you're looking for. All right, here's another one. I have a rectangle here that is 8 foot by 3 foot. So 8 would be the length. So we just say 8 times 3, because that's, remember, it's L times W. So length times width, 8 times 3. And that would be 24. And those are feet. Don't forget that those are feet squared. 24 feet squared would be the answer. So in other words, in this, there's going to be 24 little boxes contained inside of that rectangle. All right, we have a square here. The square is 6-inch sides. So we're just going to do 6 squared. 6 times 6 equals 36, and those are inches. So I'll write it square inches just so you can kind of see it that way as well. 36 square inches would be the answer for that one. Okay, now let's go back up here to this shape here real quick. And I want to show you one more thing. What if instead of this being 1 centimeter by 1 centimeter, what if each one of these boxes represented, let's say, 2 centimeters by 2 centimeters? Okay? What if it was 2 instead of 1? Well, when we number this, each one of these boxes is going to be 2, because each one of this length now equals 2 centimeters. So we'd have 2, 4, 6, 8, 10, 12. Now this would be 12 by, and this would be 2, 4, 6, 8, 10, 12, 14, 16, 18. So now we would have 12 by 18 when we do our multiplication. And, you can just come over here and do that real quick. So 12 times 18 is going to give you 16, and 1, 9, 0, 12, 6, 11, 2. 216 square units. And they were centimeters, square centimeters. Okay? Okay, now going back to our original, we said that this was 72 centimeters squared when we did it the first time, right? Now I want you to see something. I can't just take my 72 and say, oh, that's times 2 because these are 2 instead of 1 now. Because if I do that, I'm going to get 144 centimeters squared, and this is 216. So you have to be very careful not just to say, oh, these are 2 instead of 1, so I'm just going to multiply at the end. Because we're using square measurements here, each one of these are squared, you have to do it at the beginning to get the correct answer. This is going to give you a wrong answer if you just try to multiply them, just the single units and then multiply by 2 at the end. That's a bad decision. You're going to get the wrong answer. And what makes it wrong is the idea that these are square units. Each one is by 2. Okay, so be careful on that one. If they give you a problem like that, you make sure that you call each one of these its own, set of 2 rather than just measuring each one by 1 and then trying to multiply at the end. So that's all I have for you in this lesson. Hopefully you learned something there. If you missed anything, make sure to slide it back, watch it again. Go into the book, practice these. All right, you're not going to get better at these if you're not practicing them. So do those practice problems, do the homework section, and keep working hard. Do your best. That's all I've got for you. Hope you have a good one. We'll see you later. Bye-bye.